to do an IP meeting at 2 o'clock. So for my other geometry class, it's kind of the middle of their class. So I'm recording this class and then I'm going to play it for them. So when you hear me talk about the honors thing, then that's what I'm talking about. What? All right. Now we did do the most of the homework in class, although I had to spur a few of you on to actually try and attempt the things. Any questions on the homework?
5 and 6.
5 and 6, pick one.
It was number 5 that checked me up the most.
All right.
Because on the book, it said R equals H equals 5.
So that meant R and H equals, is it 2 root 5 or something like that?
Is that system? Is that it?
Yes.
I'm angry now.
Root 5, not just plain old root 5.
Yeah.
So let's see. I'll do 5. So you got pi. That doesn't work. There we go. So let's see. We got pi r, the big long square root symbol. We got r squared plus h squared. R squared plus h squared. And we're told that r and h, r equals h equals root 5. That means that both r and h equal root 5. We're just going to toss that in, Danny. Hurry up. So pi times root 5, that's what r is, times the square root of, what's root 5 squared? 5 plus 5, because h squared would be 5. 5 plus 5 is 10, so we get pi root 5 times root 10. What's root 5 times root 10? Root 50. So we get root 50 times pi, but there's a perfect square in root 50. So 25 times 2, so we get square root 25 is 5. So we get 5 root 2 times pi. There's your answer. Now, how do we write it when there's a pi involved? If you put the pi on the other side of root 2, it looks kind of weird, and you're not sure, is it underneath the radical symbol or not? So we generally write 5 pi root 2, but any one of those would be fine. Remember, multiplication is commutative. All right, anybody else? What was your problem?
Oh, we did it because me and Micah
Yeah, I saw that.
Okay, so it's 2 pi r squared plus 2 pi r h. That's actually the surface area formula for a cylinder, which we will learn next chapter. Well, r is 10. 10 squared is?
100.
So 100 times 2 is?
200.
So that you get 200 pi. This was that conversation we had towards the end of class. 2 pi rh. R times h, that would be 10 times 6 is?
60.
Times 2.
120.
So plus 120 pi. So therefore the answer is 320 pi.
1 plus 1 equals.
Say again? All right, bridge papers, here we go. Number 1, 4/3 times pi, or 4/3 pi. Number 2, 63 pi. Number 3, 32 pi. We did that one in class, if I remember right. Number 4, 288 pi. Number 5, we just did it on the board, 5 pi root 2. If you didn't write in that order, that's fine. 5 times root 2 times pi, same answer. Number 6, we just did it, 320 pi. Number 7, 12 pi. That was the cadence problem. And number 8 is 18 pi. And that was it. That was a very short homework. We're going to do something today. We're going to get 2 formulas. 2 formulas. They are somewhat lengthy, but they are very easy to understand. All right? You're going to get 2 formulas today. They're both a little bit lengthy, but they're very easy to understand. And since we just did that work for the algebra review right there, that's why they kind of did that one before the next class. You're going to see the similarity between that and what we're about to do. You need a formula that's going to involve some things like square root symbols. You should be good to go on that. All right. Calendar, nothing's changed. It's still, we're taking our test on Wednesday. I will give you packets next Friday for you to practice for your PSAT test. Like I said, I will not be giving you a class. I don't know what are your other teachers doing for those 2 days, Monday, Tuesday?
No idea.
They haven't talked about it yet? Okay, they'll start talking about it next week. But I will not do a Zoom class. I will not have anything on Teams. You're just going to walk out of my classroom next Friday with a packet, right? That will have practice problems that I highly encourage you to do, right? Because you're taking your piece out on Wednesday. It's how many minutes is it? It's 3 hours and 5 minutes, I think, is the test. Right?
The number keeps changing from 3 hours, 4 hours, and anywhere between 3 and 4.
I said at the start of this week, I said I knew it was between 3 and 4 hours. I just couldn't remember. Then I was told yesterday it's 3 hours and 5 minutes. It is everything. It is a language arts and a math test. I want to say that there's multiple sections for each one. So it's not like you're literally going to sit there for 3 straight hours and take one test. There's going to be the part A of the language arts test, part B of the language arts test, and then in between those, I believe there's a schedule like 5-minute breaks in between, and then there's a math test. The math test will have a calculator and a non-calculator portion. I believe you the non-calculator first and then calculator, and then next week, Wednesday, Thursday, Friday, we will go over what the College Board publishes as their practice test. We'll just look at what the questions look like. We'll answer them. We'll talk about them. They come in 3 flavors, easy, medium, and hard, right? I will go over every single easy question, every single medium questions. We'll do a couple of the more challenging ones, but you should be able to get the easy ones and the medium ones. The hard ones, well, they're hard. I'm not saying, well, I'm going to blow it off, but we'll spend most of our time on the easy and the medium ones. All right, homework for today is as follows: 1 through 14 all. 1 through 14 all. For my 9th graders, I got the next slide will be your homework. Two formulas today.
How many formulas is that?
5 minus 3 formulas today. How about that?
Oh my god, number.
I got a cool trick. It's the square root of
2 to the 0 power plus 2 to the 0 problems power problems today. How about that?
That's your age.
All right, we ready? Danny, you ready?
No,
Yeah, I saw it.
we were trying to find our agendas. And somehow he had mine.
Your chocolate's in my peanut butter.
Oh, yes, I know that.
Why do you park the car on camera?
What is that from?
It's from the 80s. It's for Reese's Pieces. There's a commercial and these 2 nerdy people walking down one person's eating peanut butter, one person's eating chocolate, and they run into each other. And then it's a girl and a boy. One says, "Your chocolate got my peanut butter." The other one says, "Your peanut butter got my chocolate." And they're like, "Wow, it tastes great." And supposedly that's where Reese's Pieces. Even in the 80s, we knew that was lame. All right.
Chocolate cream is separate.
Not that Reese's Pieces are lame, but the commercial's pretty lame. All right, honors kids, here's your homework. It's just 1 through 18 all, so you get more of the more challenging ones. Here we go. 2 formulas. One is going to involve arc length. One is going to do something called areas of circles, except it's not going to be the entire circle. It's going to be part of the circle. All right, here we go. You have heard of these things, or you've seen these things before. You may know what this is.
That looks like pain and suffering.
Right. It is called a cadence, called pie chart, right? And you've seen these before. Do you know what it actually is telling you? What is it telling us? It's telling us percentage, right? You take each one of these, go give a name to it.
Like the first quarter and stuff, like you had really good sales in the first quarter.
So yeah, the light blue here is first quarter, and it says you must have had very good sales there. Do you know what we call the pieces of the pie? 100% right. We call those sectors, right? And here is the key part, Matt. And
sorry, I just found something great.
I know, but let's pay attention, please. Okay. The sectors themselves, how much space in the pie that it takes up, is a percentage, and that percentage represents literally a number. The reason why we like pie chart is because you won't see numbers. You'll just see a visual representation of those percentages. We're a visual species. We like visuals. You know, we could write this out in just numerical form. You know, I don't know what the light blue is, but it's certainly more than 50%. Maybe it's 62%. Maybe the darker blue or the purple there is 25%, right? We would much rather have it visually presented to us, okay? Believe it or not, this is what we're doing, not making pie charts, but this is what we're doing today, okay? Write this down, please, box 1. Those individual pieces of the pie that I just showed you on the pie charts are called sectors. And since they're on a circle, we call them sectors of a circle. It's the area, I mean, literally the area, that's what we'll be calculating today. The area bounded by 2 radii and an arc. For those of you that need a visual representation, there's my circle. So it's the area bounded by 2 radii. In red, there are my 2 radii. And the arc that goes between them. I really tried to line that arc up, but I didn't do a good job of it, okay? But those in red here, if it was perfectly drawn, that would make a sector. So here it is in yellow. It's still, I had to freehand it. It still looks crummy. I'm not very happy with my drawing. But that in yellow there is what we'll be calculating today. We will be calculating how much is this yellow. We got a formula for it, right? The formula is medium difficulty, but it is a formula that you can put in your book of truth. Don't panic. The questions will read, what is the area of the sector? You'll look at the formula for it. You'll plug the numbers in the formula, and away you go to the answer. All right, overall questions on the concept of what is a sector of a circle. We haven't got the formula yet, but we will. Nothing? Okay. All right, 2 big ideas today. The first one is what's going to be called arc length. We're going to get a formula for that. Remember, arc length is, well, we've done arc measure, but we haven't done arc length. And I remember when I introduced this concept of the arc to you, major and minor arcs, we talked about that eventually we would get a formula for how long is the arc. We don't have that formula yet, we will today. We know arc measurement in degrees, how big it is, but we don't yet have a formula for how long is it, like you take a ruler and measure it type thing. We will today. The second one is that area. We're going to calculate how much space is in that region that's defined by the 2 radii and the arc. So 2 formulas, they're both very similar. So similar that sometimes it's hard to tell the difference between the 2. Luckily for you, you get to write in your book of truth and use your book of truth on the test. All right. So arc length, here's my 2 crummy arcs again. Arc length would be this in where the arrow is pointing to, right? That part right there in red, that's a little bit better, but not perfect. That's your arc length. And by measuring it, I don't mean angle measurements. We've already done that. I mean, literally, how long is this curved red portion right here? In inches and centimeters and feet and miles, that sort of thing. Sector area would be this whole big thing, right? Just the yellow portion, the entire thing. One formula for each one of those, one for arc length and one for sector area. And like I said, when you see the 2 formulas, they are very similar to each other. So you can't screw it up if you were asked to memorize it. All right, let's talk about arcs briefly. Recall that an arc is the distance between 2 points on a circle. That's the arc, right? The arc is that area, or I shouldn't say area, but that measurement along the circle between any 2 points. Remember major and minor arc? How many letters do we need for a major arc?
3.
How many for a minor arc? 2. So if you have 2 letters, you're talking about something less than 180 degrees. If you have 3 letters, 180 degrees all the way up to 360. Okay? So recall that we put this little, it's imperfectly drawn right here. Microsoft didn't give me an arc symbol. I don't know why. They didn't ever have the symbol. But it's you'll see it in the book, perfectly drawn. That is called arc AB right there. Arc AB is, well, it's the part of the circle that lies between point A and point B. Now remember, Matt, there's 2 directions that you can go to go from A to B. there's the short way, and then there's the long way. The long way would be more than 180 degrees. That would be a major arc. Notice we only had 2 letters. The short way would just be the shorter portion. So clearly, if there's only 2 letters, you're talking about the short path. If there's 3 letters, there's not here, but if I made that point C, right, then you could say that that would be major arc ACB or BCA, however you want to say it. Okay, so we're going to restrict ourselves to just the minor arc. Okay, when we talk about its angular measurement, how many degrees, what part of the circle it is, we put a little m in front of it, and that means the measure, and it means measure in degrees. How much of the 360 degrees is it from A to B? Okay, do you remember how you do that calculation? We had a whole chapter on it. We said that the arc is equal to, take a guess if you can't remember, and what do we call that? Well, let's just use some common sense words. We call it the central angle. Very good, right? So the arc measure is equal to the central angle. In other words, in red there, if you know that angle, then you know the arc measure. It can be confusion in this chapter because we will be talking about both the arc measure measured in degrees and the arc length measured in inches, feet, whatever.
Isn't the arc length just double?
Remember, that had something to do with arc measure, and that was the inscribed angle. Remember, the inscribed angle was equal to half of the arc measure. Okay, but we're going to be only talking about today central angles, no inscribed angles. Okay. All right, so that was the formula, which you guys at least eventually remembered. Cool, we're going to be using that today as well too. All right, so this is going to be a proof of where this formula comes from. In other words, we're going to do a formula for arc length. I'm going to show you where the formula comes from through a talking proof. I'm just going to talk my way through the proof. So arc length, not arc measure. Arc measure is how many degrees from A to B. Arc length is whatever you're measuring it, how many inches, feet, centimeters, whatever, from A to B. Okay? You got to keep that concept clear in your head, though. Arc length. So here's the talking proof. Okay, so let's say that we have a circle, and on the circle we have 2 points, A and B. Okay? We're going to need a few things. First off, I'm going to need the radius of the circle. We will call that suspiciously R. I also need the central angle. The central angle, remember, would be this part right here. Okay? So those 2 pieces parts. Now here comes the leap of faith. I got to explain this part. Okay? It turns out that the arc length will be a percentage of the entire circle, right? By the way, just visually, how much does it look like AB is of the entire circle?
A little bit less than 4.
A little bit less than a quarter. So if I know the entire circle's distance, we call that the perimeter. We also call that the circumference. And I knew that percentage, I could take that percentage and multiply it by the circumference. I could take the percent of the arc length and multiply that by the total distance, which would be the circumference. But guess what? I know that. The percent is going to be the central angle. If it's a quarter, then the central angle is going to be a quarter of 360. If it's a semicircle, it's going to be half of 360. It'll be 180. That'll be the central angle. Okay? The total distance is going to be the circumference. And luckily for us, we know the formula for circumference. That formula is formula for circumference of a circle, 2 pi r or pi d, either one. Okay? So that's what's going to get us to this formula for arc length. We're going to take the percent of the circle that's described by the arc length and multiply it by the circumference. That's the whole formula. And it's going to look like this. All circles have 360 degrees. The percent of the circle would be the central angle. That would be the x divided by 360. That's going to give you a percent. Hey, if the central angle is 180 degrees, half of the circle, 180 over 360 is 50%, right? Okay. If it's a quarter, then it's 90 degrees. 90 divided by 360 is 1/4. Okay? We take that percent and we multiply it by the total distance. The total distance is the circumference. There's your formula. We'll write down here in a second. Okay? So to figure out, now be careful, arc measure is, that's the M. Arc measure is the degrees. Arc length is the distance between A and B. We're going to write it down here in a second. Here we go. So put this in your book of truth. In yellow there is the formula for arc length. Okay, it's kind of a medium formula. It's not nice and pretty like pi r squared. It's got a few pieces going on, but it's not horrible. It's not like the distance formula or, it's more Pythagorean theorem type formula than it is a much more complicated. Quadratic formula, way more complicated than this. So it's x over 60, where x is the measure of the arc or the central angle. Either one, by the way, remember those two are equal to each other. The central angle and the measure of the arc are the same thing. Sometimes they might give you this x, I'm pointing to the bottom x. Sometimes they might give you the central angle. Those two are exactly the same. Radius is the radius. So to do this formula, I need the central angle or the measure of the arc, and I need the radius. I just need two things, plug them in, and then it's just like yesterday's homework. It's just a plug and chug thing. Arc length, arc length. Two formulas today, arc length and sector area. Here's your first one, arc length. Okay? Yeah, it's pretty short. It's not that complicated. Easily forgotten. Oh boy, is this easily forgotten.
Oh, I bet.
Yeah. All right, so this is what the problem will look like. I took this right from the book. This is what it will look like. They'll give you a circle. They'll give you an arc measure. Hey, look, between A and B is 60 degrees. It's measured. Remember, it could be the arc measure or it could be the central angle. They're both the same. And it'll say something, calculate the length of arc AB. Okay, there's only two letters, so we're not going the long way around, right? That would be the major arc. By the way, we can do that measurement as well, too. So we use our formula, our arc length formula. We know that the arc measure is 60 degrees. That's a 5 there, not an S. We know the radius is 5. Those are the values that we plug into our formula. Okay, so let's see. X is 60. R is 5. And now we have the conundrum removal. What do we do with that big honking mess right there? So what are we going to do with this big honking mess? Matt, what do you think? Okay, option number one, you grab your calculator, you toss it all in. Well, you don't have a calculator. Now what? And don't tell me you cry.
I cry.
So talk me through, if you don't have a calculator, what would be the easiest way to simplify that mess right there?
To reduce it to 6 over 36, then you could reduce that to 3 over.
About 1 over, you said 6 over 36, 1 over 6.
Times 2 by 5. I have no idea what you open
How
that.
about 2 and a 6?
I could reduce those to 1 and 3.
So what's the answer? Just multiply straight across now.
What's 1 over 3?
Just multiply straight across. What's that number?
1.
What's that?
Pi. 5.
Multiply.
Pi
5
5.
pi over,
3.
and you did that without a calculator, without any tears, right?
It's that close to
All right. Now grab your calculators
Thanks, Dad.
and do 5 pi over 3 and see what you get. What? There's no way, Matt, pi is about 3. 3 divided by 3 is 1. 1 times 5 is 5.
I was trying to leave it in terms of pi.
Oh, okay. We will do that for the next problem.
And,
I agree. Yeah, 1 point. Yeah, I got you.
Yeah.
It's about 5.2. Okay.
I will say that in the homework, it does want you to leave it in terms of pi. It doesn't say it again.
Doesn't say it again, and I'll give you more clarification when we get to homework. All right. Anyone lost on what we just did right there? Arc length formula, Are you going to remember it? Probably not. It will be in your book of truth. Are you going to remember what to do? Hopefully so. Okay. Let's do another one. All right. Sorry. Here's one where I literally took it and I multiplied by 3.14.
Yep, it's 5.2.
Thank you. You scared me there for a second.
Sorry, I'm trying to leave it in terms of pi and make my life easy, but I failed.
I like the way you're thinking because when they don't give me instructions, I will always leave it in terms of pi because it just saves me from doing it. By the way, I would never have converted 5 over 3 either. I would have left it as 5 pi over 3 and be done with it. We okay now? Danny?
Yeah.
Okay. So this one literally says leave it in terms of pi. Notice, calculate the length of, what's it say?
AB.
And
ABC.
a CB.
Yeah.
So we're doing both the major and the minor. Same thing. Okay. Remember, we're doing arc length. We're not doing arc measure. Arc measure is degrees. Arc length is literally a length. Feet, inches, miles, that sort of thing. The only bad thing about arc length, when we do arc measure, right? We know 360 degrees in a circle. So as soon as you do one of the arcs, you subtract it from 360 to get the other one, right? For arc measure. You can't do that for arc length because you don't know how big the entire circle is. So this one will require two honest to God calculations. Okay. All right. What do you want to do first? The minor or the major arc?
Minor, 'cause it looks easier.
All right. Let's do the minor arc. So what are the two values I need on this particular one? This is box 4. What are the two values?
Obviously, you need 129.
I need 129. Notice this time they didn't give me an arc measure. What did they give me?
Degrees.
This time they didn't give me an arc measure. Previous one,
Central angle, sorry.
notice where the 60 was. Now they give me a central angle. But remember, central angle and arc measure are the same thing. So the arc measure is 120 degrees and the radius is somebody.
9.
Is this just the Matt answer day?
Obviously.
Obviously. Wes, we got this? Connor, yes, no, maybe? Okay. All right, so those are the two values I'm going to throw into my arc length formula. Now, this one does say leave in terms of pi. We don't need a calculator. We can do this whole thing without a calculator, right? So, Wes, talk me through it. Your turn.
You can divide it by 3, right?
Because there's a 3 here somewhere?
Well, the 12 it can be
Okay.
4.
All right, so if we divide everything by 3, we would get 40 over 1. 120, which could be further reduced to, you know what Matt did his first time when he saw zeros?
Oh, wait.
Which would further reduce to
10. Okay. Well, just 1.
1/3. Okay. So that big honking fraction just turns into 1/3 times 2 pi 9. Anything else reduce?
3 and 9.
3 and 9. So what's the answer in terms of pi?
You're not multiplying the pi and the 9 or 3 or 8.
Remember, leave in terms of pi means we just tack a pi on. We don't mess with
2
it.
pi 3.
Well, yeah, but the 2 and the 3.
5 2.
What?
Are we multiplying? That's why I asked.
You tell me.
I guess we are.
So therefore,
6 pi.
okay. Hard, easy, medium, what? Wes?
Easy.
It's very, very easy.
Yeah, couldn't you have, like, especially start, couldn't you have done it by 6?
Or you could have realized that 120 goes into 360. 6 will work. 10 would work. Matt last time just immediately said get rid of the zeros. Well, 12 over 36 is 1/3.
That's the way I was
Okay.
taught.
Now, just to show you, fine line between calculator and not calculator, right? Now grab your calculators. If you were doing this in terms of pi, what would you do?
Parentheses.
Would you the only thing is you got to remember what's being multiplied and what's being divided. So if we were to do this with a calculator, ignore the pi, because we're leaving it in terms of pi, multiply straight across, divide by, finish my sentence, divide by 360. All right, try it. What do you get? You can do 120 times 2 times 9 in your head?
times 9, but.
No, okay. Danny, we good on this? You know what I'm asking you to do? You have your calculator?
I don't think it's
This is not a requirement to have a calculator to do this. I mean, we just did it by hand, by the way. But I know a bunch of you are going to want to say, oh, give me a calculator. Let me see. What would I do? Well, 120 times 2 times 9 divided by 360, and we get 6. Okay. Is that the whole thing? Now we got to do it. Now, like I said, previous chapter, we were doing arc measure. We found that it was 120 degrees. We just said 360 minus 120. We got the major arc. But this time, I don't know what the circumference is of the circle. I mean, I guess I could calculate it and then subtract 6.5 from it. Heck with that. Let's just plug the numbers into the formula. It's just as quick. Okay. So, talk me through it. What do you think, Ethan? We're doing ACB now. So basically, how long is it from A to C to B if I stay on the circle in inches or units in this case? So what am I going to do?
That's a good question.
What do we need for the formula?
126.
We need two things. What two things do we need?
126.
What two things do we need? Don't know numbers, names. What two things do I need?
Oh.
I need the measure of the angle and what?
Not arc length.
I need two things.
I don't know what that pi thing is called.
It's on the board. I need two things. Matt, stop.
This is the radius.
Okay, so do we have the radius?
Oh, it's 9.
It is 9. It doesn't change. The radius doesn't change. But what does change here, Ethan, is so we're not doing AB, we're doing ACB. What does change for this problem is the angle. So we need this angle from A to C to B. It's not 120. Keep talking. You almost had
I
it.
was going to say, can you just subtract 120 from 260?
And that would give you that measure. So I don't care. By hand, we calculate either one. So 240 is our angle. That is our measure of angle, or arc ACB. So 240 is my measurement of that major arc. Is everybody with me? Anybody lost on that? Well, the radius is still 9. That doesn't change on the circle. Those are the numbers we toss into our formula. So give me the whole formula, Ethan, with the right numbers in.
Measurement ACB equals 240 over 360, and then 2 pi 9.
And now we're back to reducing it. All right, let's use Matt's technique. What did he say to do with the zeros? Take them away. You got 24 over 36. What can that be reduced by?
2 over 6.
2 over 6 because what are you dividing by?
By 12.
12. Okay, 12 goes into 24 2 times. 12 goes into 36, not 6 times.
3 times.
3 times. So we get 2/3 times 2 pi 9. Anything cancel?
The 3 and the 9, and then 2's.
2's don't cancel, they're next to each other. So just multiply.
12 over 1. This is 12 pi.
It's just 12 pi. Very good. If you want to grab your calculators and confirm that, you can. That wasn't too bad. I would say this is medium, right? Not easy. 1, you got to remember the formula. 2, you got to remember what to plug in. And then 3, you got to do that math, right? What? Well, this is half of the formulas, but yes. I mean, it's just basically straight up. I mean, how else can I make it more complicated? I can't. I have to give you the radius. I have to give you an angle measurement. They could give you some symbols instead of numbers for angle measurements. What symbol could they use?
They can use, I forget, it's called like the 0.
What symbol could they use for a measurement of an angle? Okay, I like the way you're thinking, but I'm thinking of, instead of this saying 120, they could, oh, that's horrible. How about that? They could give us a right angle, right? So instead of writing 90 degrees, they'll put the symbol for 90 degrees. That's the only symbol that you'll have that could, instead of giving you, specifically what the arc measure is, or the central angle. Okay. Are we okay with that? Arc length. Arc length. All right.
We're not doing
I
that.
said there were two formulas. Now for the second formula. The second formula is the area. Look up here. Remember, the area is defined by two radii and an arc. So we're looking at the area of this sector right here, sector AOB. Okay. I'm going to do a talking proof again. So let's see. I have that the arc measure is x degrees. I know that the radius is r. Everybody with me? We're going to use the same formula. This this sector right here is a percentage of the whole darn thing. Matt said kind of looks like a quarter. So it'd be a quarter of 360 degrees, right? That would be its percentage, right? We can apply the same thing. So we can do this. Area is pi r squared. That would be for the entire circle. We simply take a percentage of pi r squared. What percentage would it be? Well, whatever percent x is of the entire 360 degrees. So the formula itself is derived from the same idea as the previous one. We figure out what percentage of this arc measure is of the entire circle. That would be x over 360. That would be a percent. We multiply it by, not by the circumference, we multiply it by the area. Once again, x over 360, x is the arc measure. It's 25%. We take 25% of the area, we get the sector area. I need two things. It's the same two things as arc length. I need an angle measurement and I need a radius. The formulas look dead similar. In fact, the only difference is one says 2 pi r, one says pi r squared. Because one you're doing arc length and this one you're doing area of the sector. Okay. I told you there was going to be pretty easy today. Can you forget that? Absolutely, 100%. It's in your book of truth and you can flip through it. You shouldn't have any problems with this whatsoever. So let's do one. Oh, we got to write that down. So sector area, the area that's bounded by two radii and an arc length. X over 360 times pi r squared. X could be either the central angle or the arc measure, either one. R is obviously the radius. Chris? Good? Jenna? By the way, those are really easy proofs too. If all proofs were that easy, geometry would be very easy. We okay?
No.
What, Matt?
Said Danny's never okay. He doesn't count.
Danny counts as much as you do, Matt.
I never okay, so I just don't answer.
You need help when you want to do.
All right, here we go. Let's do one. Yeah, I literally used the same diagram. This time we're going to do the area of the sector. I don't know what color that is, but the small sector, not the large one. Because remember, AOB could also identify the larger sector. Do you see that? AOB could also be defined as, I'm going to shade it here for you. Could be that sector as well too. So which one do they want? It says of the minor area. Okay?
That's some amazing shading.
Thank you. It's taking me years to get that right. That good. All right. So here we go. We need two things. We need the central angle or the arc measure. Well, I got that arc measure. I need the radius. The radius was 5 again. You just plug it into that formula. X is 60. R is 5. Go ahead, Matt.
Let's see. Can't see through Seth's head. His mind's moving.
It's literally the same as the previous one you did, except it says 2 pi r is pi r squared.
So get rid of the zeros.
Okay.
1 over 6
times,
Pi 5 squared, pi 25.
does anything reduce? So it's 25 pi over 6 in terms of pi, calculator. Give it to me as a decimal. I always do one as a decimal and the rest I leave in terms of pi.
13.08.
And I rounded it to 13.1. Questions? Connor? Questions? You got it? It's a yes or no. All right. I said yes or no, and he shakes his head diagonally. So I'm like, well, that could be a no, it could be a yes. All right. Calculate the area of the minor and the major sector. Okay. By the way, it's the same one as the previous one. So Micah, do the minor one. The minor one would be the smaller, this area right here.
Calculating that area?
Say again?
Calculating that area?
Yeah.
So
Talk though.
120 over 360
Times,
times pi r squared.
which R is,
R is 9.
okay. So let me catch up with you. That's what he just basically said. All right. Before you grab your calculator, let's just reduce it by hand. Not because you have to, but because it's just good practice.
1 over 3
That's 1 over 3 times,
81. 81 pi.
does 3 go in 81?
27.
What's 8 plus 1? 8 plus 1 is,
27.
9.
well, 3 goes in 9.
27.
So it's 27.
Pi.
We didn't get a calculator for that. 27 pi, look at that. By the way, when you do sectors, you are doing an area. That's why it would be in square units. When we did length, that's just standard one dimension. And so it would just be units. Like I said, mathematicians were very lazy in high school geometry, and we tend to skip the units. All right, you got to be truthful. Tell me, lost, not lost? Where are we at? Okay. You want the last one? Yes, congratulations, do it. Tell me the formula.
So, wait, we're
We're trying
trying to find this.
to find out the green part.
So you would just do the,
And you're gonna have to think about what Ethan did on the previous one. What 2 things do I need?
you need the radius
Radius is 9.
and the measure
Of the major arc ACB.
Yeah.
So what's the measure of ACB? And that's why I said, think about what Ethan did. How did Ethan, because when he figured out what's the arc length of ACB, so he needed this angle as well too. How did he find that angle?
Oh, right, he did the,
Don't overthink it. Look at the picture.
he did ACB, which equals 120 minus 360,
Okay. You said it backwards, but yes. 360 minus 120.
240.
240. Okay, so your arc measure is 240. So keep talking.
And then you would do the 240 over 360 times
Keep talking.
the pi 9 squared.
Okay.
And then you do
Matt's method.
cancel out the zeros. That'd be 2 over 3
That would be 2 over 3.
times pi 80 times 81 pi.
Anything reduce? Does 3 go into 81? 7 times. So we get 2 times 27 pi, which would be double 25 would be
Wait, double 25?
well. When we said what's 2 times 27, I'm just making an easier problem. What's 2 25s?
Or 27 times 2.
Agreed. Or if you want to do that way, I'm just saying.
And then 54 pi.
All right, 54 pi. We're not,
Square root.
and it would be in square units. All right. Yes.
Yes.
All right, we got one problem left. It's a challenging one. One problem left. It's a challenging one. All right. Look at the picture. This is number 8.
This one's pink.
Ends up being it's not bad. Do you see the picture, Danny? Okay. What's the shaded area? Where is it? Is it the whole thing? It's part of the whole thing. Could you come up, I'm not talking about with pi's and r's, just a general formula to figure out that one little tiny sliver?
Yeah. It's
What do you got, Wes?
Well, you want that, it looks like a triangle. So when you.
Keep that thought.
It would be, it's the theorem, I can't remember, like, the eight, but yeah. Can you do-
You're overthinking it for a sec. I just want a general formula for this little piece right here.
It's purpose piece, right?
I don't want anything other than just names. Like I said, ignore pi, ignore r for a second, and just look at the shapes.
But it's 90 degrees, doesn't it?
Agreed. You're concentrating. In general, if you're ever trying to find a piece of the sector,
You find the area of the sector and subtract it from the triangle.
you hear what he said? Say it one more time louder.
Take the area of the sector and subtract it from the triangle.
Right? Because the area of the sector would be the whole darn thing, yes? So area of the sector minus
Triangle.
the triangle. Well, that's what we're going to do. Everything you said was good, both of you. We're thinking in more general terms. This is usually the starting point. Well, how can I do this? Looks impossible. You're like, oh, wait a minute. Just the area of the sector minus the triangle. All right, which one do you want to do first? Area of the sector or the triangle? Okay, so let's do area of the sector. What do we need?
You need the arc measurement.
Well, what's the arc measurement?
90
Okay, and we need the,
radius.
all right, well, we got both of those. So here's what Seth and the rest of you came to. Okay. Sector area was this. We're going to type in 10 for the R, 90 for the, all right, let's do a quick reduction. 9 over 36 turns into
3 over
12, which turns into,
so 1 over 4.
yeah, because 9 goes into 36 4 times. So 1 over 4 times which is, so 1 times 100 is divided by, that turned into a 4. 100 divided by 4 is 25 pi. Well, that was easy. Look at our formula. We just did sector area. Now what do we need to do? What's the formula for area of a triangle? I'm going to throw things at you. What's the formula for area of a triangle? Somebody help me. Area of a triangle.
Wait, so base time height divided by 2?
Yes, I knew you knew it. So what's the base?
10.
What's the height?
10.
10 times 10 is
100.
divided by
2.
is 50. So it's 25 pi. Let me catch up with you. So it's 25 pi. Final formula. Area of the triangle.
25 pi minus 50.
25 pi minus 50.
Oh, you actually have to do this.
Grab your calculators. Tell me the answer. Oh, by the way, this would be in terms of pi.
And yeah, the homework, it just tells you to stop there.
Yeah.
Okay. What do we get for a decimal approximation?
78.5.
And we were doing area, so that would be in square units. Okay.
28.5.
All right. Any questions on anything we did? Questions on anything we did? By the way, this is what your homework looks like. Micah, easy, medium, hard homework?
Medium.
He says medium. Right? Medium. No questions? All right. Back it up. Remember, honors kids, that's your homework. I do want the homework. Let me have that before you split. Homework.
Honors kid.
All right, guess where you're going to be during student advisement? No, you can come to my room from now on during student advisement and do your math homework so that I can ensure that you're actually doing your homework. Danny, homework. Matt, homework.
Somewhere in here, I started it. Gotta find it. It may be in my binder. What? When I
Stuff
find
I
it,
got
I'll
rolled?
get it. Yep, I handed it. Hey, I have no idea where it is.
I have an idea where the zero goes in the grade book.
That's true.